Whenever you create a 2D platformer, RPG or side-scrolling game, you will encounter a task of making a character movement script. This may seem like not such an easy thing to do, and some new developers might be a little overwhelmed by some linked topics like animations and camera control, but trust me, it's not that scary. In this tutorial, I will show you how to implement a simple character movement together with animations and character follow mechanism. For this tutorial I use an already prepared level. It's based on a tile map and uses colliders for the terrain. If you don't have a level or you want to learn how to make something similar to this one, you will find a link to the tutorial upon that topic in the description. So let's get started. In this scene I already have a background, a map with colliders and a player object with a sprite renderer. Before we jump into the character movement implementation, I want to start with an idle animation. This will improve the visual appearance of the character. If you don't use an animation in your game, just skip this step. The easiest way to add an animation is to select the object that we want to animate and then open the animation window. If you don't have that window, just go to the window menu, Animation, and select Animation. Once we have it, we simply need to click on the Create button and then create a new folder. Let's name it Animation. And then save the animation clip file. I will name it Player Idle Animation. Animation clip is like a set of properties that changes over time from one state to another, and a timeline is a tool to define these changes. In our case, we want to update the sprite property of our character. Unity offers a very simple way to create that kind of animation. All we have to do is to drag the sprites we want to use for the animation into the timeline. I will quickly select the idle animation sprites and drag them into the timeline. And I will also change the samples to 12 to slow down the animation. We can use a play button to see how it looks. Now we can go ahead and add components that are necessary for the movement. The first one is rigid body 2D. Thanks to that component, our character will be affected by the physics. Let's select our player object and click on Add Component, search for the rigid body 2D and hit enter. Let's now press the start button and see what happens. As you can see, our character reacts to the gravity and falls down out of the screen. To make him stay within the map, we need another component, and that will be Capsule Collider 2D. So again, let's click on Add Component and search for the Capsule Collider 2D. Now we need to update the collider bounds to fit the player sprite. Let's click on the Edit Collider button and try to make it more or less like the player sprite. That should be fine. Now we can hit play to see that everything works. As you can see, our character collides with the ground now. Now we can move on to the coding part. I will split that task into two things, getting the input from the keyboard and then using it to change the position of the player object. I will create a script folder, so let's right click, create folder. And then I will create player input script. Let's open it. First we need to declare the variable to hold the movement input. Let's call it horizontal input. And then inside the update method we have to read the horizontal input. To do it, we're gonna use an input class. So let's write horizontal input is equal to input dot get axis and write horizontal. This method will return values from 0 to -1 when we press the left arrow and from 0 to 1 when we press the right arrow. You may ask how Unity knows what are the keys behind horizontal, and the answer is simple. This is all defined in the input manager. You can easily access it by going into the Unity, Edit and Project Settings. And here you have the input manager. Inside we have already a few predefined input options, and one of them is horizontal. And as you can see, the negative button is left and a positive button is right. We are not gonna change anything here, so let's just close this. Once we have a horizontal input, we can now create a movement script. So let's go and create another script. I will name it player movement. And let's open it. First, we need to define a move method. So let's create a void move. And this method needs to take a horizontal input as a parameter, so let's write float horizontal input. Next we need a reference to the rigid body component, so let's define it. Private rigid body to the player body. And we also need a movement speed variable, so let's create a public float movement speed. Inside the start method, let's assign a reference to the player body variable. And let's set the default movement speed to 5. Now we can go back to the move method and add an implementation. So if horizontal input is different than 0, then we want to change the velocity of our player. So let's write float horizontal velocity is equal to horizontal input multiplied by movement speed. And then player body velocity is equal to new vector 2 horizontal velocity and player body velocity y. One more thing to do, let's make this method public. Let's go back to the player input script and let's add a player movement variable. Let's assign it in the start method. Player movement is equal to game object get component player movement. Now we need to create a fixed update method and let's check if horizontal input is different than 0, then player movement dot move, and we pass the horizontal input. You may ask why we use the fixed update method instead of the update one. So basically we always have to use fixed update when we do something with physics, and in this case we update the velocity. Let's go back to the Unity and add those two scripts to our player object. Let's just drag them into our object. And let's hit play. As you can see, our player moves, but he also rotates. This is because we applied velocity to his body, but we didn't freeze his rotation. So let's quickly fix that. We just need to select the checkbox freeze rotation inside the rigid body component. And let's hit play again. Now everything looks fine. The next thing we need to do is to update the player object when we change the movement direction. We want the player to face in the left direction when he moves to the left side and face the right direction when he moves to the right. So let's go to the player movement script and add facing right variable. Next we need to add check facing direction method. So let's write private void check facing direction. And we're gonna use horizontal input as a parameter. Inside this method, let's check if facing right and horizontal input is smaller than 0, then we have to flip the player. And else, if not facing right and horizontal input is bigger than 0, we also want to flip the player. Next, let's define the flip method. Private void flip. To change the player direction, we can use a scale property. All we have to do is to multiply the x value by -1. This way, every time we call this method, character will flip. So let's write var player scale is equal to transform.localScale, and transform local scale is equal to new vector 3 player scale x multiplied by -1 player scale y and player scale z. Let's also change the facing right to not facing right. Then let's add check facing direction to the move method. And let's pass horizontal input to this method. Now we can go back to the Unity and see how it looks. And as you can see, player changes the facing direction. Now it's time to add a movement animation. We want to have a different clip than for the idle state. So let's select the animation window and then click on the player idle animation and click on create new clip. Then let's save it into the animation folder and let's name it player movement animation. And as previously, let's drag the appropriate sprites to this clip. And let's update the samples to 12. Let's see how it looks. But how do we trigger the movement animation if we already have an idle animation? We have to go to the animator window and define a transition. I will not go too deeply into explanation of the animator component, but I will give you a brief intro so you understand what is happening. As you can see, our two animation clips are already added here and we can drag them and place however we want. You can also spot that the idle animation is connected with the entry item by this yellow arrow. This basically means that the idle animation is the default one. We can easily change the default animation by right click and selecting set as layer default state. But we want the idle animation to be the default one, so let's go back. So how do we move from the idle animation to the movement animation? We need to use a transition, and a transition defines what animation should be played as the next one under what conditions. To create the transition, we have to use a right click, make transition, and then connect this arrow with the next clip. Of course, our intention is to player the movement animation only when the player starts to move, so we have to define a condition. On the left side, we have a list of parameters that can be used to create a condition. It's empty so far, so let's create our first parameter. It's gonna be type float, and let's name it movement. Now let's select a transition arrow. Let's expand the settings, and we want to disable exit time and fixed duration. Now let's define the condition. Let's hit the plus button. And as you can see, the movement parameter is already selected. So if the movement is greater than 0.01, then we want to transition from the idle state to the movement state. We also need a transition from movement to the idle state. So let's create another transition. And let's select it, disable exit time and fixed duration. Another condition, but this time let's change it to less than 0.01. Now we need to somehow pass the movement value to the animator component. So let's go to the player movement script. Let's create the animator variable. And let's assign it in the start method. Animator is equal to GameObject, getComponent, animator. Next, inside the update method, let's use an animator and let's use method called setFloat. Write movement and pass the absolute value of player body velocity x. Now we can go back to the Unity and see what are the results. As you can see, animation starts when we start to move and stop when we stop. Now we can go ahead and implement jumping. So let's go to the player input script. And this time let's define jump pressed variable, private bool jump pressed. And inside an update method, let's check if not jump pressed, then jump pressed is equal to input get button down jump. And the button behind the jump name is a spacebar. Now let's go to the player movement script. We want to define a public float jump power variable, and let's say it's gonna be 700. Then I will go ahead and add jump method. And the implementation is very simple. Let's just write player body, add force, and let's use new vector 2 with 0 on x-axis and jump power on y-axis. Now let's go back to the player input script, and inside fixed update, let's check if jump pressed, then player movement jump, and jump pressed is equal to false. Let's now go back to the Unity. Let's select our player object and let's update the gravity scale to 2.5. This way player will fall down faster and jumping will look more natural. And let's hit play. And as you can see, jumping works, but there is one issue. We can jump in the air. To fix that, we need to check whether the player actually stays on the ground. We want to create a ground collider, so let's select our player object and add an empty game object inside it. Let's rename it to ground collider. And let's position it on the bottom of our player. Something like this. Then let's add a box collider to it. And update the bounds so they are a bit smaller. And we also want this collider to be a trigger. This way it will notify us about the collision but will not affect the physics. So let's check the is trigger checkbox. Next, let's create a ground collider script. And let's open it. First, let's add a variable called isGrounded. We can remove start and update method because we don't need them. And now we have to create a method called onTriggerStay2D. And inside this method, we want to check if other game object layer is equal to ground. I will go to the Unity and check the value of ground layer, and it's 8. So the ground is equal 8. And if that is true, then isGrounded is true. We also need a method onTriggerExit2D. And again, if other game object layer is equal to 8, then isGrounded is equal to false. Now let's go to the player movement script and let's create a reference to our ground collider. This time it's gonna be a public ground collider. And then let's change our jump method, check if ground collider is grounded, then we can jump. Now let's go to the Unity, select our ground collider object and add ground collider script. Next, let's drag the reference to this script into the player movement. And now let's hit play. As you can see, we can only jump once. It's finally time to add a jump animation, so let's click on an idle animation and create a new clip. And this time, let's save it as a player jump animation. This time I will drag the jump sprites. And again, change the samples to 12. And let's go to the animator. I will add another parameter. This time it's gonna be type bool. And let's name it isGrounded. This time we want to make a transition from any state to the jump state. And that is because we can jump both when player is moving or standing still. So let's drag it here. And let's create a transition from any state to the player jump animation. Let's select that transition. And let's disable fixed duration. We also want to disable can transition to self because we don't want to transition from jump to jump. And let's add a condition isGrounded equal to false. And now we have to define transition from jump to the idle and to the movement state. So let's create a new transition from jump to idle. Let's disable the fixed duration and exit time and add conditions movement and isGrounded. So we want to transition into the idle if the movement is less than 0.01 and isGrounded is true, and the same for the movement. But this time we want to transition if the movement is greater than 0.01. We also want to play the jump animation only once, so let's disable loop time. Now I will go ahead and update the player movement script. So inside the update method, let's write animator set bool is grounded is equal to ground collider is grounded. And let's go to the Unity and see the result. As you can see, animation looks very well. The last thing I want to show you in this tutorial is a very simple method to add a camera follow to your game. For that we're gonna use a component called CineMachine. First we have to import it, so let's go to the window, package manager, and search for the CineMachine. And let's click install. Next, let's close this window. And now all we have to do is to go to the game object, CineMachine, and virtual camera. This will create a virtual camera object in our scene, and what we have to do is just drag our player into the follow field. CineMachine has a lot of options, but I will not go through them in this tutorial. I just wanted to show you an easy way to add a follow mechanism. And now let's hit play and see how it looks. That's it for this tutorial. I hope you enjoyed it. Please leave a like and subscribe. Let me know what you think in the comments below, and I see you in the next video.